So let's recall some of the core variables in your circular motion. So circular motion, we have the radius, time period, that is time for one around the circle. Then we have frequency, then you have angular velocity, that is the velocity at the rate at which an angle is per se covered. So we have the SI unit to be radians per second. Then when this is happening, we'll have something called as linear or if not tangential velocity. Then we have centripetal acceleration, tangential acceleration. Centripetal acceleration is the one which keeps the body in circular motion. Tangential acceleration is the one which changes the linear velocity. I hope you guys remember all of this and the formulas. Then you have angular acceleration, mass of the object, and centripetal force. This is the next set of things that we're going to learn. Okay, we'll directly apply the formulas and figure it out. So frequency and time period, they are inverse of each other. And so we have one more formula, time period is 2 pi r by v, if not 2 pi omega. So basically omega is 2 pi by t. And v and omega has a relationship. I have it here. V is equal to omega r. Then you have theta omega t, that is your change in the angle, right? And this is your angular acceleration. Then you have your v, the linear velocity is equal to omega r. Your tangential acceleration is alpha into r. And then you have centripetal quantity, which is equal to v squared by r, if not omega r. So this is one more expression that we're going to derive now. So derive as in, it's kind of extension, that's it. It's nothing much over here. So we'll be using it basically. Okay, so let me make use of the board and okay, before the board, let's talk about this. You guys remember this? So we have a time scale, okay, that you guys can ignore. Radius is 100 pixel over here. Frequency is 0.5, means what? For every 2 seconds, one round is completed. So you can have a look. Is it so? Now let me increase it to every second one round is completed. So frequency and time period are inversely proportional. So angular velocity is how much of angle is covered per second, right? Speed is your speed. Centripetal acceleration is the force that needs to act on the object so that it continues to move in circular path. Then what else should I show here? Yeah. Okay, so let me pause it. I'm getting a headache. Okay, so let's have a chat on this. Bit of revision, nothing else. So we have a lot to. Just a second. Okay. Now let's look at the terms that we happen to see. So the usual ones, radius, that I'm not going to tell. Time period, time for one round. So it takes 10 seconds for it to complete one round. Time period is 10. Then the frequency is 1 by 10, right? Then angular velocity is like, okay, within 1 second, how much angle is being covered? That's your omega. Okay, so that's your angular velocity. And then you have your tangential stuff. So that is your linear velocity, and pulling it inward. Pulling it inward is done with some force. And that's your centripetal. Oh yeah, sorry. You have acceleration as of now. Force is what we'll look at. So we have your centripetal acceleration pointing inward. Tangential is perpendicular to centripetal and pointing in the direction of force or pointing in the direction in the change of acceleration and stuff. Okay, I'm not going to detail. That statement is something that you guys have to be clear with. Alpha is your angular acceleration. How fast or slow, or how fast the angle is changing, right? How slow the angle is changing. Language is left to you guys. Okay, then what else? So we have frequency and time period, all of that you guys know. I think I wanted to talk about omega and your V. So V by R. Then I wanted to talk about what else? AC and AT if I want to list it. These are the two things. So what is AC and what is AT? AC is your V square by R. If I substitute V square over here, we have omega square R, right? And AT will be alpha into R. Like how V is equal to, where is V? Oh yeah, how V is equal to omega R, you differentiate it and you'll end up with this. Okay, so what else should I recall? Oh yeah, the net acceleration or total acceleration. That's what I was thinking, if you guys remember. Okay, so I think now I covered everything. Okay guys, if anything, anyways, you guys can go back, have a look at the chapter, open your formula list. So please recall everything because we're going to make use of that, and then one step more, that is we'll figure out the force. That's it.